Hi logic students, now that we have covered the rules of chapter 7 and we thought back of all the other rules that we learned in chapter 6, we can do a proof together so you can see how a proof of an argument is accomplished in chapter 7. Here's an example from exercise, well, it's the first exercise in section 7.6, which contains various exercises that require you to symbolize an argument and then prove that it is valid. So the first thing we want to do is symbolize it. First premise, all carpenters are precise. So you know that universal premises are rendered as universally quantified conditionals. So we'll go line 1 for all x. If x is a carpenter, then x is precise. I'm using the letters provided by the textbook. Second premise, some handy persons are carpenters. So there is an x such that x is a handy person and x is a carpenter. There's an x such that hx and cx. The conclusion that we want to prove, we'll set it aside because it has to appear here in the proof, but we cannot enter it in the proof, of course, is some handy persons are precise. So there is an x such that x is a handy person and x is precise. Okay, so let's see how to do this. Normally what you want to do is you want to initially get rid of the quantifiers and then reintroduce a quantifier. So these quantifiers here are sort of problematic in the sense that you can't do anything inside the parentheses with these formulae that you could manipulate and use to your advantage unless you get rid of the quantifiers, because the quantifiers serve as the main logical operator. So the first thing in the order of business in a proof is to try and get rid of the quantifiers, and then obviously at the end you'll need a move to reintroduce a quantifier so that you make the complete conclusion. Okay, you know that there are rules that allow you to get rid of quantifiers. There are the instantiations, and it's always a good idea when you have an opportunity to use both universal instantiation, which you could use on premise 1, and existential instantiation, which you can use on premise 2. It's always a good idea to use existential instantiation first, because you know that there's a restriction on existential instantiation that you have to introduce a new constant. You cannot use a constant that was used before. So it's always best to use it first. So let's instantiate premise 2, the second line. We can just pick whatever constant we want. Let's just pick a. So from line 2 we can infer h, a, and ca. This is justified as 2 existential instantiation. Okay, now that we have introduced this constant, we can use universal instantiation and instantiate the first premise to the same constant. That way we'll be working with HA, CA, CA again, PA, and it will all be in the same constant, so everything will be much easier. So from line 1 we can have if CA then PA by 1 universal instantiation. Okay, and now let's see. We need to find something to do with these lines 3 and 4. You cannot break up a conditional, but you can break up a conjunction. You have the rule of simplification that allows you to help yourself to either one of the two sides of the conjunction. So on line 5, we can simply enter CA, which we get from line 3, simplification. And now it looks like we can do a simple modus ponens. Remember, modus ponens is the pattern that if P then Q and P entail Q. So here we have if CA then PA, CA, therefore PA. So we can infer PA from 4 and 5 modus ponens. Okay, so we're getting closer because it looks like if we manage to put together HA and PA, then with existential generalization we'll be able to make there is an X such that HX and PX. So we have secured the PA, and should be fairly easy to get the HA, because again we can get that from line 3 by simplification. It's a conjunction, so we can grab the first element of this conjunction. So on line 7 I will enter HA by line 3 simplification. Okay, and now we're close because we can put together HA and PA by conjunction. It's the rule that allows you to take two separate lines and put them together with and in between. So HA and PA by lines of 6 and 7, conjunction. And because we have HA and PA, certainly there is an X such that it is H and P. That's the rule of existential generalization. So from line 8 and EG, we have been able to produce the conclusion of this argument, and so we have been able to show that the argument is valid. Okay, so remember, your strategy is normally to try and get rid of the quantifiers, which are always part of the premises, so that you can work with simpler expressions. Remember, when you have a choice between existential instantiation and universal instantiation, use existential instantiation first, like we did here on step 3. And then once you have these shorter formulae, you can manipulate them and shorten them even further by using all these rules that are now familiar: simplification, modus ponens, conjunction, and so forth. And then your final move will be to reintroduce the quantifier through some form of generalization. I hope this helps. Let me know if you have any questions, and I'll see you in our classroom.